A few of you were saying that you had some difficulties with the homework from Unit 9, Day 12 and 13. So I'm just going to go over one question from each topic and show it's not that crazy. So, the midline of a trig graph. Whoopsie. So, it says determine the equation of the midline of the following graph. Now, if we look at the graph carefully, we can see that it starts in the below and it goes up and down. So this is actually a sine curve, not a cosine curve, so that's the first thing to notice. You need to know which kind of curve you're working with, but not for this question. But if your graph starts in the middle of its graph and then goes down and comes up again, so this is a sine curve. All right? If it started differently, we'll see a cosine curve in a minute, but it'll have a different midline. But the midline passes, your graph starts in the middle, it goes up to the top and down to the bottom. So if it starts in the middle of the graph, it's a sine curve. Now, this line passes through as -4. So this is a horizontal line through -4, so this is y equals -4. Not that complicated. Y equals -4. It says that's the correct answer. So this graph shows one complete sine curve. If we saw this graph, this is a cosine curve. We can tell the middle of this graph is actually, it starts at the top. So this is a cosine curve. So it starts in the middle of the graph. It's a sine curve. If it starts at the top, it's a cosine curve. So it starts at the top, it goes down, it goes back up. So the middle of this between 3, which is the top, and the bottom, which is -3, is 0. So 0 is our midline. So the equation is y equals 0. Correct. Not going to do any more. Let's take a look at the amplitude. Amplitude should be a little bit easier to find. So the middle of our graph here is -2. That appears to be the middle. If you look at the graph closely, it starts at its middle point. So it starts at -2. That's the middle of the graph because it can go up and down from there. All right. The amplitude is the distance from the middle to the top. So the distance from the middle to the top in this case is 2 units. So the amplitude is 2. Now the amplitude is just a number, not an equation, so we don't have to write y equals. Next, period. So let's take a look at the period. So this graph, it completes, is this a sine graph or a cosine graph? It's important to know. Looking at this graph, it starts in the middle because it goes up and then down, and it completes a full curve at 3 pi. All right, so 3 pi is where the curve completes. So that's the period. So we're going to write 3 pi. This one says find the period. I'm just looking if any of them say find the frequency, which they don't, which is fine. So finding the period shouldn't be too hard. This one completes the sine curve at 2 pi as well, because we can see it does the up and down, and it finishes at 2 pi. Let's take a look at the next problem. Trig graph discovery. All right, so we start with a standard sine curve, so that means by default this is 1. So the amplitude is by default 1, the frequency is by default 1, completing the graph at 2 pi, and the midline is by default 0. So this is, if I press the try button after filling this in, it should say nothing should happen to the graph. I press try, nothing happens. So in this case, the amplitude does not appear to change as I move from one graph to the other. It appears the midline changes, and it goes down 2 units. So I'm going to change the d value to -2. The graph will shift down 2 units. It will say we are correct. Okay. The next problem is also a shift downward. I'm just going to go to a new problem, see if there's any other problem types in these. They all appear just to be shifts. Oh, this one seems to change the amplitude. So this is a cosine curve. Instead of going up to 1, it goes up to 5. So I'm going to change the amplitude to 5. and that's not quite right, so it must have also moved up. So I'm going to go make that back to 1 just so we can go back to normal. So the midline of this, the top of this graph is 5 and the bottom of the graph is -3, so the midline is actually 1. So I'm going to increase this to 1, and the graph will move up. And now I can see the distance from the top to the top is actually 4, not 5. So here is our graph. All right, so the first topic here was to just use either the midline or the amplitude. Let's take a look at version 2, level 2. So this one, it appears the graph just shifts up. So I'm going to skip this one, try and figure out what makes it level 2. This one, here's where negatives come into play. The midline of this graph appears to be at -1, because that appears to be the distance between 1 and -3. So I'm going to go to -1 here. That'll move the graph downward. Now you'll also notice the graph has flipped over, so that means I'm going to make this a -1 to flip it over. So that's, the amplitude is still 1, but it's flipped over, so it's -1. And I'm going to change the amplitude to 2, because that appears to be the amplitude of the graph by looking at it. And that's it. So this one adds the negative amplitudes to it. Let's see if a different problem does something else. This one appears just to have a negative amplitude and a midline. Seems fine. All right. Part 3. Okay. So in this case, we have a cosine curve. We could tell because it starts at the top of the graph. So the top of the graph is where it begins. Then it goes down. So that's already a cosine curve. If it starts at the bottom, by the way. So if we had a graph that would start at its bottom, that would be a negative cosine graph. But this one starts at the top, so we know it's a positive a value. The midline appears to be 0, so this is going to be like 5, I guess. It goes up to 5, so let's just try and stretch it out. Now, it's kind of hard to see like this, so I'm actually going to make that back to a 1 just so I can see a little better. This graph completes its full sine curve at 10 pi, so the period is 10 pi because that's where the graph ends. So if I want to find the frequency, I use the formula b equals 2 pi divided by the period. I'll just call it p. So b is equal to 2 pi divided by 10 pi. So if I simplify that, I get b equals 1/5. So that means it completes a fifth of a sine curve in 2 pi, which makes sense because it takes 5 full 2 pi's to make it to the end of the graph. So this is going to be 1/5. And yeah, that should be it. Oh, see, I stretched the graph to the correct size, but I still need to change my amplitude to 5. And that is the graph. I'm assuming most of these problems are just like this one. Let's take a look at part 4. This time it says, try writing fractional values or pi. So these are the ones where it's a little harder to calculate the period or the frequency. So let's take a look at what we have here. Firstly, our graph appears to have moved down 1 unit, so let's move it down 1. So down 1. That's the midline. Also, the graph appears to be upside down, so we're going to have a negative a value. Put in a negative here. Appears to have an amplitude of 2, so we're going to make it -2. And now I have to figure out where this graph is completed. Now, it tells us a cosine graph. That's important to know. So it starts at the bottom, and it goes all the way up and back to the bottom. One time over here. So this is not a really easy number to read, this point where the curve completes. So I'm just going to see if I can find a place where a curve completes. So I see at 6 pi, we have 1, 2, 3 full curves. So it does 3. The frequency will be 3 in 6 pi. So that means it does 1 curve in 2 pi. So 3 curves in 6 pi. So logically, if I divide both of these by 3, I get 1 curve in 2 pi. So I'll just leave this the way it is. Oh wait, I can't do that. So 3 curves and 6 pi. Oh, wait. I'm sorry, I'm looking at the curve that I started with, but the curve that they give us ends at 12 pi. So this is not correct. So it's hard to see their dashed lines under there. So their period is 12 pi. Using the formula, b equals 2 pi over the period. That's b equals 2 pi over 12 pi, which is 1/6. So we're going to do 1/6. And the graph should stretch out to the correct place, and it did. Let's try and do a different one. All right, so you'll notice that the scale is no longer written with pi's. Odds are that means our b value is going to be using pi in it. So firstly, this is a cosine curve. The amplitude is negative, so let's flip it over. It appears to have shifted up 2 units, so let's just put in a +2 in the d value. Okay, and then we just have to get our graph stretched to the right place. So this graph starts at the bottom of its graph, and it means it ends at the bottom of its graph, so it does that at 3. So the period of this graph is 3. So the frequency is 2 pi over 3. So I'm just going to write 2 pi divided by 3. And we get the correct graph. And all other problems here should be some variation of this. If you have any questions, just let me know. I will help you to the best of my ability.